Okay, welcome once again to today's video. Today we are going to be looking at some interesting machine learning techniques for regression problems and how it is performed in Python. Okay, we look at some performance matrices to compare their performance so that we can select the best model out of these four models. Okay, so without wasting much time, let's get right to it. Okay, so to start with, we just import our libraries. We need pandas to read our data sets. We need a linear regression model because that's one of the machine learning models that we are considering. We use the decision tree regressor. Since our problem is regression problem, we use the linear regression decision tree regressor, and then we need the random forest regressor with a support vector machine. If it was a classification problem, then we would use SVC, which is for classification, but since it is regression, we use the SVR. You get it? That's for regression problem. And then to split our data set, we need a library called the train test split, okay, from sklearn.model selection. And then we will need the standard scaler so that it will scale the numbers of each of the columns for us to one scale. Okay, and then we will need some metrics such as the mean squared error, the r squared, the mean absolute error to check for the performance of the model. Okay, yeah, so to import the data, if you want to import the data in in Jupyter Notebook, you just go to the home file and then you just have to go here, upload. Okay, when you go to upload, it will take you to your home window where your file is to select it. Okay, to select it. So when you select it here, you see a blue a blue pop-up here to upload. Okay, so just click on it and your data will be uploaded. Okay, yeah, so here I've named my data climate data. Okay, so to view a portion of my data, I use the data.head here. Okay, so this is my data. I have yield, minimum temperature, maximum temperature, rainfall, and sunshine here. Okay, so you can see the values for rainfall is pretty higher. That is why we needed the standard scaler. Okay, so that it will scale all the numbers to one scale. Do you get it? Now to view the shape, I can simply use the data.shape and it will tell me that I have 28 rows and 6 columns, as you can see here. Okay, all right, so to check for any missing value in our data set, we use this code data.isNA. If you are checking for null values, you can use data.isNull. Then I'm summing it to see the numbers of the missing data sets in my data. Alright, so I can see that in here I have no missing value. Yield I have none. Minimum temperature, but in rainfall and sunshine I have one missing values. Okay, now to take these missing values out so that I will get a discrete data. I just named I just dropped the missing values here, so using data.drop NA, and to drop them, and when I view it again to check for any missing values, you can see that there is no missing value here. Okay, so right now when I view the shape of the data, I now have 27 rows and 6 columns because one row have been deleted. Okay, yeah, so to 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 perform the machine learning, I have to split my I have to define my x, that is the independent variable, and then my y, the dependent variable. So right now my problem is I am taking the climate variables as my x, as my independent variable, and then the yield as my dependent variable. Okay, so to do that I just drop the year and the yield so that the rest will be my x, and then the y will be my data one dot yield, so which means my y is my yield. Okay, right, so we can now view some of the x, and using the x dot head, and this is what we have. So you see we have the four climate variables here, excluding the year and the yield. All right, so we use the standard scaler so that it will scale all the numbers to one scale. Okay, so you see 22, 31, but this one is pretty higher, so this particular code will just use one scale for them. Okay, so to split our data, we use the x train, we use this code, right? And then we use this library, the train test split, to split our x and our y. Then this test size, we set it to 0.2. What this does is that I'm saying that 20% of my data set should be used for testing, and 80% of my data set should be used for training. Okay, the random state, what this one does is that if you don't bring this one, it means when you run the code again, it will select different training data set. Okay, it will take samples of the data set to train. When you run it again, it will change again, but when you set the random state to 0, then it means it is going to fix the first one that it selected. Okay, so when you run it again, it will still maintain it. All right, so now we fit the linear model um, using the linear model equal to the linear regression, because we are using the linear regression here, and then we fit the model with our training data set, the x train and the y train. Okay, all right, so after we fit our model, now we use the model to predict our x test. Okay, now we use it to predict. Now after predicting, how do we know the accuracy or the performance of the model? Now you can use the r squared, the MAE, MSE, and then the RMSE. Okay, so this is our actual y, and then this is the predicted y. Okay, so to see so this one will give the r squared. Okay, and it's the mean absolute error. That's the mean absolute error here. So with the RMSE, when you set the squared to false, it is going to take the square root of the mean squared error, and this one actually is printing these values. Okay, so we can see that the r squared for the linear regression is pretty lower, which is not good, and then the mean squared error is not that close to 0, which is not good too. And as you know, the closer the r squared to 1, the better the model, and then the closer the MAE, MSE, and the RMSE to 0, the better the model. Okay, all right, so now we go on by fitting the decision tree model here with using the decision tree regressor. We set the random state to 0, then we fit it with our training data set. Okay, after that we predict it using since we set it with DT model, right, the decision tree model, we predict it with the X test, and then to check for the accuracy we use this one, and then you can actually see that the R squared for the decision tree is a bit higher as compared to the linear regression model. It is a bit higher, yeah, so which is good, and the MSC2 is pretty okay. All right, so let's go on by fitting the random forest model, and then this is the random forest using the random forest regressor, and set the number of estimators to 100. Okay, and we set the random state to 0. We fit our data with our training data set, and then when we predict it, we are going to get 0.79 or 0.80 approximately for the r squared, which is quite higher than the decision tree and the linear regression model. Okay, so and the MSC2 is pretty okay. So that is for the random forest model, the r squared, the MAE, and then the rest. Okay, so that's good. So let's go on by fitting the support vector machine. Okay, so remember I said for the support vector machine we use the SVR, which is the support vector regression. Okay, so we set the kernel to RBF. We have different types of the kernel. We have the linear, polynomial, but here we use the RBF, which is the radial basis function, and it measures the similarity between two data points, so which will be useful here. We go on by fitting our model with our training data set, and let's look at, okay, and then we predict it. So let's look at the matrices, the performance matrices of this support vector machine. So you can see that the support vector machine, the R squared is also, is like, yeah, it's also okay, but it can be compared to the random forest and then decision tree based on their performances. Okay, and then the mean squared errors too is also okay. So right now, so you can base on these performance matrices to select the best model. Now you, if you want to extend your code, you can go on by doing hyperparameter tuning. And what the hyperparameter tuning will do is that it will pick different parameters for each of the model, and it will select the best out of each model. Okay, so you can go on by doing that. All right, so right now you know how to select the best model, and using the R squared and then the MAE and MSE or the RMSE. Okay, all right, so thank you very much.